Hello everyone. In this video I'm going to cover three lessons. Lesson 2.6, 2.7 and 2.8. Let's have a look at the first one. Lesson 2.6, graphs of basic functions. So first of all I want to start with continuous function. A function is continuous over interval of its domain if you can go over that interval without lifting your pencil. So let me show you what I mean over here. Let's say this is my function f. So as you're seeing, to be able to graph this, we are fine up to this point, right? But to move on, I have to lift off my pencil. So you're gonna say that this function is not continuous function. But in math, we say it this way. That this graph is continuous here and here. So let's say from negative infinity up to 3 and 5 should be bracket to infinity. So this function is continuous over this interval. Okay, it's not continuous all over the place. There is some restriction. Excluding here is continuous over this interval, right? So let's have a look at those ones. Describe, are they continuous or not? This one is continuous, right? But there's no need to lift off your pencil. So this is a continuous over negative infinity to positive infinity. But on this one, as you see, we are fine. But here there is a open circle, so we're gonna jump over, right? So which means 3 shouldn't be there. We cannot include 3. I'm gonna go like this: continuous over this interval, negative infinity. You're gonna come all the way up to 3, but do not include 3. So open circle and 3 to infinity. And here, as you're seeing, it's a continuous here. I can just go and draw it. So I'm gonna say continuous over what's my domain? Here, we can disregard this 3. I don't need that one. I'm talking about continuous over its domain. So my domain here, 0 to infinity, right? 0 to infinity. That's how I say it. On this one, continuous over what? Over which interval? So here it's going this way, right? So my interval again, what's my domain here? Domain should be 0 and negative infinity. Negative infinity to 0. But this function is continuous over this interval. This function is continuous over this interval. So those are your turn examples. Please try to solve those examples. Find the continuous interval. So make sure, guys, that I'm gonna use this website a lot, desmos.com. Make sure you have this. Make sure you bookmark in your Google. So we're gonna use this a lot. Here I'm gonna show you a few well-known functions, and we have to know those functions a little bit. And we have to know the domain, range. That's this graph, and as you're seeing, it has been increasing over negative infinity to positive infinity, and it's continuous. Those are kinds of basic information about this function we have to know. And this is a x squared function. Even if you forgot those, everyone, we can do this. We can just graph this and talk about those, and which is super easy, right? But we have to know those information: domain, range, increase, and continuous. Let's say for this one you don't know how to do so, right? But let's say I got this function square root of x. So I go to Desmos website, right? y equals square root of x, right? I just graph it and then we just talk about this. So domain should be those x numbers, 0 to infinity. We see domain 0 to infinity. And then range should be my y numbers start at 0 going up and up, 0 to infinity, right? It's here. So we got this, increase. So as you see, it has been increasing here. So 0 to infinity is going to be increasing, right? And then continues or not. So like as you see, I can just draw this without lifting my mouse. So it's going to be continuous over 0 to infinity. Okay, even if you forgot this, just graph and see so you can remember them. Those are important information here. So second part of this lesson 2.6 is this kind of function. And we're going to do this. We have a given function here. How do we find f of 5? So we're going to do this. So f5 belongs to which family? Does it go here or it goes here? I gotta decide this. 5 is bigger than 2. So I gotta work here then. So my x is 5. I just take this, like write in this function then. So it's going to be 5 plus 1, which is 6. So f of 5 should be equal to 6 then. So that's my answer. But on this case, we got 0, right? My x should be 0. And 0 is not bigger than 2. So I should work here because 0 is less than 2. I should go here and plug in here. Negative 2 times 0 plus 5. So 0 plus 5. So it should be equal to 5. So f of 0 should be equal to 5 then. On the second example, we're going to do the same thing. Look, what's my number here? F of negative 2. My x is negative 2. So it belongs top or bottom. Negative 2 is here, it's less than 0. So I should work on here. 2x plus 3. So plug in here. 2 times negative 2 plus 3. Negative 4 plus 3. So it should be equal to negative 1. So f of negative 2 should be equal to negative 1. Like same as here, f3 is what? Like that is something bigger than 3. So I should be working here. So x equals 3. I should be working on here. Let's plug in here. 3 squared is 9. So it should be negative 9 plus 3. So it should be equal to negative 6. So which means f of 3 should be equal to negative 6 then. So let's move on to next one. So those are your turn example. So could you please find f of 5 and f of negative 5? Let's put the question marks here. Again, one more time, Desmos. We need this a lot. We're gonna use this a lot. Lesson 2.7. Look, on lesson 2.7, we are gonna do so much graphing, so many graphics. And main task of this lesson is find the transformation, like find the transition. What happened there? Is it like move up, move down? Is it like stretch or shrink? Like what happened there? That's my basic question here. Compare the graph of each function to its parent function. But as you see, we have a square root stuff here. So my parent function should be y equals square root of x. So this is my parent function. Alright? I'm going to graph this and I will graph this. I will compare them. So I will see what happened there. What's the transformation there? So let's go to Desmos again. Oh, I already have this one. Cool. And then what's the a? Square root of x minus 4. Let's graph this as well. Minus 4. So as you've seen, my graph like went down, right? So I'm gonna say, oh, transformation of this graph is down 4 units. Well, that's what I do. If we have a look at the second one, okay, let's graph the other one. X plus 4, right? Check. Yes. So as you see what happened here, this is my original one and that's the other one. So it moved left, right? So I'm gonna say B should be moved left 4 units. Now that's the transition happened there. And lastly, let me check C, negative square root of x. Here we are. So as you're seeing, it goes this way, so it's reflected over x-axis. So I should say over here, look, C should be reflected over the x-axis. So that's the transformation happened here. Okay, so that's the whole goal of this lesson 2.7. All right. So let me move on to the next one. So transformations of yx squared. I'm gonna do the same thing here. I'm gonna graph this. That's my parent function x squared, and I will graph them. I will see what happened there. I will see the transformation there. So let me y equals x squared. Okay, that's my function. Cool. And second one should be x squared plus 3. So here I should put x squared plus 3. So as you've seen clearly, it just moved up 3 units. So I should just come here and say moved up 3 units. That's all what I say. So if I look at this one, x squared minus 3, like as expected, it's gonna go down. So I'm gonna say move down 3 units. Oops, down 3 units. What about this one, x plus 3 squared? So this one, let me go x plus 3 squared. So as you're seeing, it moved to the left this time, right? It moved to the left this time. Left 3 units. So on this one, like as expected, move right 3 units. But just to make sure, let's graph and see. X minus 3, as you're seeing, it moved to the right. That's all what I do here. Oh, I already solved this, right? So we can get rid of this one. So here we can do the same thing, transformation of those. So 1 over 3, 1/3 x squared. Let me 1 over 3 x squared. So as you're seeing, it's stretch, right? That's my original red one. Blue one is a new one, so it's stretch. All right. On this one, I'm gonna say stretch, right? But on this one, 3x squared. Let's put the 3x squared, so it just got narrower, right? So it shrank or like got narrower, right? So like objective of this lesson 2.7 is like what happened there? Like what's your transformation there? All right. So we are done with lesson 2.7. So let's move on to 2.8. So it's time to move on to next topic, which is lesson 2.8, functions, operations, and composition. So first of all, like on the first part of this lesson, we're gonna see how to add functions, how to subtract functions, how to multiply, and how to divide those functions. All right. Let me show you my first example. So here we got two functions, right? F of x and g of x. Find each of following. So I'm looking for f plus g1. Like this is how I do. I'm gonna add them, right? So I'm gonna find f1, and then I'm gonna find g of 1, and I'm going to add them up. All right. So let's find f1. So to find f1, take this 1, go to f function. So it should be what? 1 square plus 1. So 1 square is 1, 1 plus 1 is 2. Let's calculate g of 1. So take this 1, go to g function, plug in here. 3 times 1 plus 5, 3 times 1, 3, plus 5 is 8. So if I add them up, so it's going to be equal to 10. So which means like f plus g of 1 should be equal to 10, and that's my answer here. I'm gonna do same thing on b, like f minus g3. So I'm gonna find f3 first, and then I'm gonna find g3, and then I will subtract them. So to find f3, take this 3, go to f function, plug in here. So it should be what? 3 square plus 1. So this should be 9 plus 1, so it should be equal to 10. So let's find g of 3. So plug in here, this should be 3 times 3 plus 5, 9 plus 5, so it should be equal to 14. But this is like f minus g, right? So I'm going to subtract them. So if I subtract, f minus g of 3 should be equal to negative 4, and that's my answer here. Okay, nothing big deal, easy. So let's move on, like same question. I'm gonna do C and D here. Like C is here, so I can do D here. So f times g5. So as expected, I'm gonna find f5. I'm gonna find g5, and then I will multiply them. So let's do so. f5, so plug in here, 5 square plus 1. So it should be 25 plus 1 should be 26 times, right? G of 5, plug in here. It goes here, 3 times 5 plus 5, 15 plus 5, so it should be equal to 20. So 26 times 20, so it should be 520, I believe. Yes, here we are. So that's my C is, let me write over here one more time, f g5 equal to 520. That's my answer. What about D? Let's have a look at D. So to do what, I'm gonna follow same step. I'm gonna find f of 0. I'm gonna find g of 0, and then I will divide them. F of 0 is what? Take this 0, plug in here. 0 square plus 1. So which is, this is gone, it is 1. What about g of 0? Plug in here, 3 times 0 plus 5. So it should be equal to, this is gone, 0. 0 plus 5 is 5 anyway. So it should be 1 over 5, which is my answer. But this is how we do it. So those are your 10 examples. Please pause the video and solve those questions. So how do we calculate this if we don't have an equation to plug in? Like how do we calculate if we have a graph this time? Same thing. I'm not going to do something crazy. Same thing. So let's say on this one, I'm looking for f plus g of 4. Which means what? Which means I'm gonna find f of 4, I'm gonna find g of 4, and I will add them up. F of 4, so like as remember, like f4 should be what? Which means like when x is 4, what's my y value? x4 is here. If I go up all the way here, so I can see corresponding y number, which is 9. So it should be 9. So g of 4, like go take your 4, go to g function this time, which corresponds to this number, which should be 2, right? So if we add them up, so it should be 11, right? So f plus g of 4 should be equal to 11. That's my answer. So let's say, let me do fg1. I don't have much space. Or let me do this off, like this is a good question. So f minus g negative 2. Like same thing. I'm gonna find f of negative 2. I'm gonna find g of negative 2. and at the end I will subtract them. F of negative 2. Like get your negative 2, I should go this way, and it corresponds to here, so negative 3. What about this part, g of negative 2? But here, even if you go up, even if you go down, there is no way to reach g function. So this one should be undefined. So undefined minus something, undefined plus something, whatever. So it should be undefined anyway. Alright, that's my answer. Let me copy paste this. And on this slide, I'm gonna do the last two. Plus and minus here. And here I'm gonna do f times g1. Which means I'm gonna find f of 1, I'm gonna find g of 1, and let's multiply. F of 1. Get your 1, go to f. It's gonna go here. 1, 2, 3, 4, 5. So this one should be 3. And g1 should be equal to 1, as you see. So f times g1 should be equal to 3. That's my answer. Let's have a look at the last question here. F over g. So I'm gonna find f0. I'm gonna find g0, and then I will divide them. F of 0, like when x is 0, y should be 1. And g of 0, like here, oh, it's going to be 0. Oh, 1 over 0. So if you divide any number divided by 0, so that should be undefined. So that's my answer here. So those are your turn examples. Please pause the video and try to solve these examples. So what about here? What do we do here? Let's say I'm gonna go with this one first here. How do we find this? So if we have a table, I'm gonna do the same thing. It doesn't matter actually. So like f of 0 divided by g of 0. And like 0 goes to what? Let's find f0 first. Like my x is 0. In fx function, it corresponds to 1. So top part should be 1. But when x is 0, g function corresponds to like 0. So I'm going to put that 0. So it's going to be undefined. And now let me do this one as well. So it should be f plus g4 should be what? f4 plus g4. So let's find f4. Like 4 is here. In f function, it corresponds to 9. So f4 should be 9. g4, like x corresponds to in g function, so it must be 2. So f plus g4 should be equal to 11, which is my answer. So please do those are your 10 examples. So on this part, I'm going to show you composition of functions. Okay, this is called a composite functions, and it's not multiplication. Like we don't multiply here. It's composite functions. So let's have a look at it here. F of g of 2. So as you see here, like this x goes to g first, and then we will go to f. Let me show you what I mean. So if we have this, which means it's equals to f g2. So like remember order of operation, like you do inner parentheses first, right? So let's find g2 first then. g2 is what? So which is over here, right? That's my g2. So let's plug in there. 4 over 2 minus 1, 4 over 1, which is 4. So right now I seen that g2 equals 4. So which means I can plug in here 4, right? Because g2 is 4. So as of right now we are looking for f4 basically, because g2 equals 4. So let's calculate this. To find f4, I should go to f function and plug in that 4. So 2 times 4 minus 1. So 8 minus 1, which is 7. So this is my final answer. Okay, let me go here. Final answer. So which means like f of g of 2 should be equal to 7, not 4. Okay, let's have a look at B right now. Let's see how we do that one. Let me copy paste and erase this work here. So you can see this work up here. So let me work on B here. So as instructed, I'm going to take this one, go to this function first. So it should look like this, g of f of negative 3. So first of all, I should evaluate f negative 3 first, f of negative 3. So to evaluate this, go to f function. 2 times negative 3 minus 1, negative 6 minus 1, it should be negative 7. So which means f of negative 3 equals negative 7. So I'm going to take this and go to here. Because f of negative 3 is negative 7. Replace them. So as of right now, I'm looking for g of negative 7. So to calculate this, I should go here. 4 over negative 7 minus 1, which is 4 over negative 8. Right? That's my answer. If we simplify, I should get 1/2, right? So in conclusion, g of f of negative 3 should be equal to negative 1/2, which is my answer. Yeah, I want to show you one more example and then you will do your turns. But let me do one of this. So let me do, I want you to do this one, but let me do this one. G of f of 25, which means g f 25. So let's find this first. F of 25 is what? So if we go here, square root of 25, which is 5, which means like this one should be equal to 5. So as of right now, I'm looking for g of 5. So let's go here. 5 plus 3, they should be equal to 8. So g of f of 25 should be equal to 8, which is my final answer. Please pause the video and try to solve those questions, everyone. So last part of this question, I will do this too and you will do this too, and we're going to be done with those topics. So this time we don't have a number, so how do we evaluate them? So let me show you. So this one means f of g of x, am I right? But we don't have a number, so let's go this way. Let's take g of x and write in f function. So what was the gx function? Which is over here, right? So 4x plus 2. So right now, I'm going to take this and put in the f function, which is over here. So it should be equal to 4x plus 2. So f of g of x equals to square root of 4x plus 2. That's my answer. But here is vice versa, but same step, which this means g of f of x. What was the fx function? We know the fx function, square root of x, right? So I'm going to take this, write in g function, so this should look like this, right? 4 square root of x plus 2. So which means g of f of x should be equal to 4 square root of x plus 2. That's my answer. And could you please pause the video here, have a try to do those. And we are done with these topics.